The next situation we're going to explore is x times y, the quantity raised to the fourth power. So when we have two things being multiplied inside the parentheses, when you're going to raise it to a power, you still keep them in the parentheses. So xy times itself, xy 4 times. If I rearrange those where all the x's are together, I have 4 x's together times 4 y's, and just rearranging that. The reason I'm allowed to rearrange that is because of the commutative property of multiplication. And how many x's do I have total? Well, 4. How many y's do I have total? Well, being multiplied, 4. So a fast way of doing this problem, instead of writing it all out every time, is the 4 is going to go both to the x and to the y. It's as if the 4 exponent is distributing, which is why we call this the distributive property of exponents. So if we have a and b, be real numbers and r is an exponent. So a and b, there's two bases on the inside, and the one exponent is going to both bases. It just gets distributed a to the r times b to the r. Okay, so we have a lot of examples here. These are quite intensive because they're getting a little harder here. So this 2 is going to be distributed to every single base. Now, a lot of people forget that negative 1/3 is a base. So we have negative 1/3 being squared. Then we have x cubed being squared. And then we have y squared being squared. Now, most of you probably won't write out all this work because we know whenever we have a 2 and a 2 next to each other, that just multiplies to get 4. When we have a 3 and a 2 next to each other, that's going to multiply to get 6. And then the 1/3 squared, that means negative 1/3 times itself, negative 1/3. Because they're a number, I'm going to work it out by itself. So we have negative 1 times negative 1 is positive 1. 3 times 3 is 9, so we have 1/9 x to the 6th, y to the 4th. So not only did I use the distributive property of exponents, I also used the power property of exponents where I had to multiply the two exponents that were right next to each other. All right, here we have, actually this is more of a power rule. 5 times 2, that's going to be x to the 10. 3 times 4, that's going to be x to the 12. And now, after I've used the power rule, now I'm going to use the product rule where I have two bases, two exponents. Now I actually add the exponents and get x to the 22. All right, our next problem, we have a 2 out here. The 2 is going to distribute to both bases. The 3 has to have an exponent of 2, and the y has to have an exponent of 2. Now, on the next part, we have 2 times y cubed. Notice the cube is on the inside of the parentheses. This 3 is not going to distribute to the 2. This 3, because the thing right before it is the y, not the parentheses, is just going to stay 2y cubed. And the orange, 3 cubed is 9. And the blue basically stays the same. Now when I put these two together, 9 times 2 is 18. Y squared times y cubed, we add the exponents, two bases and two exponents we add to get y to the 5th. Our next problem, we have 2 is going to go to all bases. I have 1, 2, 3 bases. The 3 is a base, 3 squared. The x is a base. X cubed squared is going to be x to the 6th. When I distribute, I'm just basically multiplying to the exponent. Y squared squared is going to be y to the 4th. On our next problem, we have part of the problem, we have the 3 that is being applied to the whole parentheses. Again, there's 3 bases here. So we have times 2 to the 3, x to the 3, y to the 4 cubed, that's multiply, we get 12. Let's finish this up here. 3 squared is 9. In red, we have 2 cubed. 2 times 2 times 2 is 8. And now when I finish this, we take 9 times 8, which is 72. Then we have x to the 6 times x to the 3. There's two bases and two exponents. That means we add to get 9. And then for y, I have y to the 4 and y to the 12. Again, two bases, two exponents. We add and get 16. Our next type of problem includes a fraction. So we have x to the 7 divided by x to the 3. So if I think about that just as the definition of exponents, the definition would tell me we have 7 x's on top divided by 3 x's being multiplied in the bottom. And because division is the opposite of multiplication, one of these x's and one of these x's can divide out, another one of the x's and another one of the x's, and then one more x and one more x. This leaves us with 1, 2, 3, 4 x's on the top. So what's a fast way of going from x to the 7 divided by x to the 3? Well, keep the base the same and just subtract the top minus the bottom. Another way of thinking about it is because there was more x's in the top, then the leftovers after you cancel should be left in the top. So the quotient property of exponents says if a is any real number and r and s are integers, then a to the r divided by a to the s, notice the bases have to be the same, you can just subtract. So similar to when we did the product rule, and the product rule means you add the exponents, like x to the 3 times x to the 4. When you multiply two powers, you add their exponents. And when you divide, you're going to subtract their exponents. So the quotient rule is kind of the opposite of the product rule. So let's practice these. We have x to the 10 divided by x to the 4 without writing out 10 x's because nobody wants to do that. We would prefer to use the rule, right? We just subtract and get x to the 6. Again, the x's are the same. I take the top minus the bottom, and that gets me x to the 2. X to the 15 divided by x to the 14. Really, nobody wants to write x 15 times and 14 times to reduce. What we're going to do is take 15 minus 14 and get x to the 1, and the shortest way of writing x to the 1 is really just x. Our next type of problem is very similar to our last one. We have x to the 3 over x to the 7. So it's kind of the same, but backwards, right? And you might think, oh, well, this is going to be kind of the same as the last one, but it turns out we're actually studying something a little bit different. We'll start out the same. All right, notice that after you have 3 x's on the top and divided by 7 x's on the bottom, one x divides out, and another x divides out, and another x divides out. And how many x's do you have left? Well, it turns out you have 4 x's, but they're all left on the bottom. So the way we write that is 1 over x to the 4th. Now, if we applied the rule that we just learned, the quotient rule, we can see that if I just take the top minus the bottom, that would get me x to the negative 4. So my question is, which one is correct? Should the answer be 1 over x to the 4, or should the answer be x to the negative 4? Well, this is exactly what we were studying. We're trying to get you to understand that these two things are the same thing. 1 over x to the 4 is the same thing as x to the negative 4. But when you're answering problems, all this unit and all throughout the rest of the semester, you never want to leave your answers with a negative exponent. You want to turn them into the fraction if you can. So the rule that we just were learning is called the negative exponent property. If r is a positive number, then a to the negative r is the same thing as 1 over a to the r or 1 over a raised to the r. Either way is going to be the same thing. So let's do a couple examples. So we have 3 to the negative 2. I can rewrite this as 1 over 3 squared, which in turn turns into 1 over 9. Because the negative in the exponent tells you to put it in the denominator. So 4 to the negative 3. We don't like negatives in the exponent, so that tells me to move it down to the denominator, because that's what the rule says. And then 4 cubed, that's 1 over 64. Okay, well, this next problem already is in the denominator. So the negative in the denominator tells you to move it up to the numerator. So we have 3 to the positive 2 in the numerator, And because there's nothing left in the denominator, we can write over 1. So that's 9 over 1, or really just 9. Now I have a fun little story going on with this problem because negative exponents can be a little bit tricky. So I kind of have a little story that I think might help. So if you think of let's say you're the landlord of an apartment building, you have some tenants living upstairs and some tenants living downstairs. And some of your tenants aren't happy where they're living, and you as a landlord is going to make everyone happy. If your tenant, A, has a negative exponent, that means he's not happy where he's living. So where is tenant A living? He's living upstairs. So he's not happy, so you're going to make him happy by moving him downstairs. Okay? What about tenant B? Tenant B is already living upstairs. His exponent is already positive, so you should just leave him there. He's totally happy where he is. Don't mess with him. How about the next one? C to the 5. Tenant C, is he happy where he's living? Sure. So we're going to leave it downstairs because he's already happy. He's fine. He likes it downstairs. But tenant D is like, no, I don't like it downstairs. I would prefer to move upstairs because his exponent is negative. So you're going to move the D to the negative 6 upstairs and it becomes D to the positive 6. So that's one way that I like to think about negative exponents. So on the next problem, let's think about it the same way. The 5 has a positive exponent, is an invisible positive 1. So where is this guy living? Well, anything that is a whole number is going to be a numerator, so they're all living upstairs. You can think about that as over 1 to remind you. So 5 to the 1, he's happy, he's living where he wants to. But the X tenant is not happy. Do you see how the X tenant doesn't belong with the 5? This is just 5 times X to the negative 4. It's the X to the negative 4 that's not happy. So the X to the negative 4 moves downstairs and now becomes positive 4, and now it's happy where it's living.